Hi to all the students. I am audible to you guys, right? So let's start this session. Hi everybody, welcome to the session where I can clearly see a lot of students in the chat. We have Vidya, welcome to the session Vidya. We have Khushi, Balaji, Abhirami, Anjali, Anushka, Riya, and I'm pretty much sure a lot of you would be joining, others will be joining. Do share the session as much as possible because in today's class we are actually going to be doing up some of the toughest concepts of chemical bonding all at once. So the names of those topics are going to be Fajans rule. We are going to talk about VSEPR theory. We're talking about the shape of the molecules. We are also going to talk about a lot of different things. Okay, so these are the major ones, and there are going to be topics like dipole moment, and a lot of different stuff is going to be there. I am assuming this chair is coming actually in the way. I'll keep it aside. Hai na? Good. So now, guys, if I would ask you, till now, is it really clear to you, each and everybody, that what is actually the electronegativity and how do we calculate the difference between the electronegativity, because that is going to be very much important. If there's any student who can actually tell me, sir, I am having problem, or you have some doubt, let me know, because as soon as I am going to jump into the dipole moment concept, it is very much important for you to know what is electronegativity and what's exactly happening. Okay, amazing. For those who are watching me for the first time, my name is Luv Mehan. I am a graduate of IISc Bangalore. And if you haven't followed my Telegram channel yet, do join it. The name is Luv Mehan JEE Chemistry, and do follow me on Unacademy as well. For that, you have to install the app, and if you have the app, every student should follow my profile so that you can actually get to know which all free classes and the paid classes I am taking up over there, so that it can actually help you to do better in your examinations. And yes, let's talk about the Telegram channel that you should follow. There's one more, which is JEE English Unacademy. The link of all these Telegram channels are there in the description. The description is entirely written for you guys only. Okay, so do remember that. And 2021 students who are preparing for advanced, there's a crash course from my end. And for the students who are actually preparing for 2022, all the batches, all the courses I have actually completed are for 2022 recently. The whole physical chemistry is covered. The whole physical chemistry is completed for droppers and freshers. And apart from this, guys, 2023 and 2022 students are having new batches, Spark and Shine batch, where all the teachers are teaching in English, and which is going to be really helpful for those who really cannot understand Hindi. If you are the one who's actually trying to find a batch where these are the teachers who are actually, so the Spark batch over here is with the top Telugu educators, so they are actually going to teach each and everybody in English, is what you have to remember. And for 2022 and 23 students, guys, there are so many batches which start every week, every month. So there are batches which are always going to be there for you, and Unacademy brings regular batches for you guys so that none of the students have to go with the recorded sessions. We are against the recorded sessions. Do remember this. And for the students who are actually preparing for 2022 and they want to kickstart their preparation, and the droppers I'm talking about, so you have to enroll to USET, USET. So this is a scholarship test where 1,000 rankers, first 1,000 rankers are getting up scholarship up to 100%. What is the code that you guys have to apply? The code is LUVGURU, LUVGURU. Everybody in the chat, write this code so that everybody else can remember this. And guys, one more thing. The examination is going to happen. It's going to held on 11th and 12th September. So do remember this. It's happening on Sunday. Do remember. And guys, pay attention. The limited registrations are there, so you have limited seats for this test. And for those who are actually going to start their preparation on Unacademy, you should remember, on Unacademy you get the best educators. You might not be having these good educators around you, and we in Unacademy bring and choose a lot of best educators onto the platform so that you never have to compromise with the quality education and with the most affordable price. So guys, you have the best educators in Iconic and Plus subscriptions. You have live classes where you can ask your doubts, notes, and the PDFs from the teachers are going to be there. Structured courses are going to be there so that you actually know when these lectures, when these courses are going to end. Live test and quizzes happens on the platform. personal coach, study planner, study material, expert guidelines, test analysis, and a lot of features are there, which are again going to help you guys whenever you are actually preparing for the JEE examination and even for the NEET examination as well. So if you are a JEE or a NEET aspirant, do not forget to use the code LUVGURU, LUVGURU, to get your 10% off. And that is the discount. And I am recommending 12 months of subscription to 2022 and 24 months of subscription to 2023 students. Do remember this. And let's dive into the chapter. चलो, लव गुरु कोड है, गलत मतलब निकालने की जरूरत नहीं है बिल्कुल भी. Yes, absolutely correct. It's just for fun. The code is just for fun. I mean, anyhow, I am a teacher, right? So teacher in Hindi is Guru, correct? And my name is Love. So what can I do? You know, it's not my fault. My parents actually gave me this name. So you have to deal with my code, which is Love Guru, okay? And now let's move ahead. We're talking about chemical bonding. So over here, you should remember the first topic that we are diving into is going to be the polarity of a bond. When does a polarity happens in a bond? You should remember. See, let's talk about hydrogen and let's talk about chlorine. So how many electrons are getting shared? If there is one dash, that means 2 electrons. So there is 1, there is 2. How many lone pairs does chlorine has? You see, chlorine having valence electron, which is 7. 1, 2, 3, 4, 5, 6, and this is the 7th one. And chlorine takes one more electron from hydrogen to complete its octet. This is what we saw in the previous class. I am giving you a recap actually. And now hydrogen wants its duplet to be complete so that it can have a 1s2 electronic configuration just like helium. So hydrogen takes 1 electron of chlorine and these 2 electrons in total are getting shared. Whenever there are 2 electrons getting shared, there's one covalent bond. Covalent means sharing is happening. Now guys, pay attention. Over here, what are we really looking at? Which one of them is more electronegative is what we have to see. Do you remember the approximate value of electronegativity of chlorine? It is somewhere around, the EN value of chlorine is somewhere around 3.2, 3.3. Okay. And when we talk about the electronegativity of hydrogen, it is somewhere around 2.1, 2.2. Okay. So these are the two values that you have to remember. Now, do you see the difference of electronegativity? If yes, now let me know which is more electronegative. And surely the answer should be chlorine is more electronegative because the number over here is high. And anyhow, halogens are one of the electronegative elements. So yeah, so chlorine is more electronegative. So now let me know, guys, which is going to pull? Because we saw, right, electronegativity is all about the tug of war. Who's actually going to keep the electron much more closer to it themselves? And over here, as chlorine is more electronegative, can I clearly write something like this? Just an illustration to tell you where the electrons are more. So this is the electron of chlorine and this is the electron of hydrogen. What I'm trying to show you is that the electron of hydrogen is much closer to chlorine, all thanks to electronegativity. So ultimately the charge on chlorine should be slightly higher, right? So that's the reason whenever, see, it's not entirely with chlorine. It's not entirely with chlorine, but still closer. That's the reason we write partial negative. This sign means partial, okay, negative. And hydrogen is the one which is actually having its electron much farther. It's not completely gone. Then we are going to write over here which is partially positive. Partial negative, partial positive. The electronegative one is always partial negative. The electropositive one is always partially positive. Clear? Yes or no, guys? Let me know. And yes, do mark the attendance. Hit the like button. And yes, let's move ahead. So this is what we are showing over here. So either you can denote these, this polarity in the bond through partial negative and partial positive character, or you can actually show this. What is it? What is this, showing? It actually shows that the electron density is more. Wherever you see a bulge, it means the electrons are more towards the chlorine. And whenever you see, less area covered, that means there is less electron density available. But partial negative and partial positive is a much better way to show that. Okay. Now guys, one more thing. What is the direction? What is the direction of dipole moment? We'll talk about what is dipole moment, okay? So first of all, know the direction. It is all, it's very easy. Wherever you see a plus sign, partial positive, make a plus. Okay. Wherever you see a negative, partial negative, make a minus. And now you have to make an arrow. How to make an arrow? Something like this. From positive till negative. That is always a direction of a dipole moment. Yes, amazing. Lakshika is giving me an answer over here. Dipole moment is equals to charge into distance of separation. Amazing. We'll talk about that. Okay. So whenever we talk about dipole moment, the symbol over here is mu, which is equals to the charge. How much charge are we talking about? Into how much far away these charges are going. So what are the charges over here? Partial negative, partial positive, and how far these charges are going to be, that's the R. Distance of separation, how far these charges are going, the partial negative and the partial positive charges. That's what we're talking about. So do remember this formula, boys and girls. And now let's talk about what is a dipole. Actually, this is how we calculate. But a dipole moment is a vector quantity. So guys, always remember, whenever there is a vector in left direction, whenever there is another vector in the right direction, but if the magnitude of both the vectors are same, then the net resultant vector is going to be ultimately 0, right? They both cancel each other. This is what we have to remember in the case of dipole moment, because right now whenever we're talking about cases like HCl, now how will you understand? Partially negative, partially positive. This is the direction of dipole moment. Now let's talk about something else. Guys, pay attention. When we have carbon, double bond O, which is more electronegative when we compare carbon and oxygen? Think about it. It's obvious, right? When we go left to right, carbon, nitrogen, oxygen, fluorine, left to right across a period, the electronegativity increases. Oxygen is partially negative, carbon is electropositive, so partially positive. Clear? Let's make the dipole moments for each bond. The polarity over here is this. The polarity over here is this. Clear? Are these dipole moments going to cancel each other? Yes, they are going to cancel each other. So over here the mu value is going to be simply 0. So if they are actually really opposite to each other and the magnitude is same, and how will we get to know that the magnitude is same? When the element which is having a bond with oxygen, it is also making a bond with the same element. When the elements forming up the bond with the central metal is same, central atom is same, then the magnitude is going to be same. So do remember that. If oxygen is more electronegative, amazing, right? So 180 degree, 0 dipole moment. Yes, even if you're going to talk about the shape, over here the bond angle comes out to be 180 degree. The shape of the molecule comes out to be linear. But we'll talk about the shapes later. I am going to teach you how you can actually remember the shape of any molecule. Okay, so we'll talk about that. Let's do it for different types of molecules. Now let's talk about water molecule. Oxygen, how many valence electrons? 1, 2, 3, 4, 5 and 6, right? Correct? These are the electrons of hydrogen. Now guys, pay attention. Is this a lone pair? Yes. Is this a lone pair? Yes. Now you should remember which is more electropositive? Hydrogen. Because there is a partial positive, there is a partial negative, partial negative, partial positive. What is going to be the directions of dipole moment? Towards oxygen, towards the electronegative element. What should be the net dipole moment? When one vector is in the upward direction, but not exactly up, not exactly vertical, they're actually coming over here. When both of them are coming like this, it's a common sense, right? If you put a water flow in this direction, this direction, what is going to be the net water flow? In the upward direction, right? So that's how it is going to be. That's what you have to remember, boys and girls. This is what you have to remember. And in a lot of books, sometimes in very small books, handbooks, it is not told you. This is not told to the students. I'll tell you what is exactly happening over here. There's one more thing that we do not have to neglect. The dipole moment is also shown by the lone pairs. So guys, pay attention. I'm going to show you the lone pairs. This is one lone pair. This is second lone pair. And they also show dipole moment, but away from the element. And exactly then the net dipole moment, that I'm making it more bold, is away from the hydrogens towards oxygen. So this is what you have to remember. Yes, sir, O2 is also En here. En electronegative, not O2. Oxygen is electronegative over here. Hydrogens are electropositive. So do remember this. Now we will practice more. So be ready. Now what we have, if we have beryllium F2, how many electrons does beryllium have? 2 valence electrons. If there is one fluorine coming up, one more fluorine coming up, forming 1 covalent bond each, single bond, then what do you have to remember? The net dipole moment. Fluorine is more electronegative than beryllium, and yes, beryllium fluoride is what we are talking about, difluoride. This is what it is going to be. Are these both dipole moments going to cancel each other? And the correct answer to this question is yes. Guys, come on, you have to be active. Cancel out the effect. So mu 0, amazing Mark. Wow, today I am having so many students who are really active. That's what you really require to crack any examination. Never feel, scared while answering up the questions. Even if you're going to be wrong, do not worry, I'll correct you. But stay active in the chat, okay? Amazing. So now, this is what you have to remember. Now we're talking about boron trifluoride. Boron, how many valence electrons? 3. Dipole moment, net dipole moment. So if one person is trying to go into this direction, your friend, one more friend is trying to go into this direction, and one more friend is trying to go into this direction, and all 3 of you guys are actually tied with a rope, where will you go? Let's say all of these 3 kids are having the same strength, then nobody is going anywhere, right? That's the reason. So all of these 3 dipole moments are going to cancel each other. The net dipole moment of this molecule is again going to be 0. Amazing. Trigonal bipyramidal, the net dipole moment is going to be 0, but only all these 3 should be same. All these 3 elements should be same. Do remember that as well. Now let's talk about ammonia. How many valence electrons with nitrogen? 5. Lone pair. Now what is going to be the direction? This is plus. I wanted to make plus, okay? So ultimately, because of all these bonds, it's going upward, net. And even with the lone pair, it's going upward. So do remember that. Therefore, the net dipole moment is in the upward direction over here, okay? Away from the nitrogen, upward towards the lone pair. This is the dipole moment because of the lone pair is what you have to remember. Okay, correct. So over here, Lakshika is writing tetrahedral dipole moment towards upward. Okay, amazing, good. Now let me know about this. Carbon, hydrogen, 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 hydrogen. Where is going to be? This is also tetrahedral. Where do you think what is going to be the dipole moment? Is it going to be 0 or non-zero? The correct answer to this question is 0. Because if you are going to talk about which one of them is more electronegative? Technically, if we talk about carbon is more electronegative. So over here, this is how it is going to be. A positive, yes. All these 4 are going to cancel each other. And in this scenario, Dipole moment, the net dipole moment of this molecule in the tetrahedral formation when all 4 elements are same, it's going to be 0. So do remember this, they are going to cancel each other. Okay, na? Now in the case of boron trifluoride, we know it. In the case of carbon dioxide, we know it. In the case of carbon having 4 chlorines, same, right? Tetrahedral, all elements are same, around carbon, mu is going to be 0. Yes, amazing, right? Guys, now you would be thinking this is easy. That's the reason. This is the most scoring when the chemical bonding comes in examination, whether it's NEET or JEE. Do remember that the highest weightage of in the NEET examination and in the JEE examination, if we talk about chemistry, chemical bonding is the number 1. Okay, do remember that. Now over here, what are we really going to talk about? The cis and the trans isomers. So if there's any class 12 students, they will be able to know this. If you are not aware with the cis and trans isomers, don't worry. Whenever I'm going to teach you the GOC, the organic chemistry for class 11 students, I am going to tell you, but I'm going to give you some glimpse. So let's talk about something. Whenever you have carbon double bond carbon and there are 2 similar groups, something like a methyl group and a methyl group, but when the both similar groups, these are similar and these are similar, when they both are on the other carbons, on the different carbons and on the same side, see they are same side but on the other carbons, then this formation is going to be the cis formation. And when we talk about the formation over here, the trans, then the similar groups are actually on the again different carbons but opposite to each other. So this is exactly opposite to each other, so this is where it is going to be trans. This is trans. Now we will talk about the dipole moment. So do remember this. Now in the case of trans, you will always see the dipole moment which is going to be minimum. Let's talk about this. As these groups are opposite to each other, let's say there are chlorine and chlorine as well. Again, as they are opposite to each other, the dipole moment is going to be the least. But when we talk about, let's say, now instead of CH3, I'm showing you guys chlorines, okay? Pay attention. Chlorine, 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 chlorine. Now what is going to happen over here? See the dipole moment? They are going to cancel each other to a very great extent. But now over here, are they really cancelling each other? Exactly, no. So the net dipole moment over here in this case is exactly going to be upward. That's how it is going to be. This is what is shown over here. In the case of cis, the dipole moments usually of the cis isomer have higher dipole moment. Okay, that's what. Clear? Yes or no, boys and girls? Let me know. Trans gonna cancel each other. Amazing, outlaw sky. Let me know your name. Mark, let me know your name. And we have Divi Verma as well. Amazing. We have Nitya. Amazing. Chalo, let's move ahead. And over here, guys, boys and girls, let's summarize things. But do you have to really remember the molecule and the values by heart? Never. You never have to remember. But you should exactly know when it is all going to be 0. I'll tell you. So guys, whenever the hydrogen that we're talking about, guys, always pay attention when delta En is 0. When delta En is 0 between 2 atoms which are actually forming a bond, then ultimately the covalent bond is going to be non-polar. Hydrogen, hydrogen, nitrogen, nitrogen, carbon, carbon, oxygen, oxygen, similar to this. Okay, so do remember this. CO2, what did you see, boys and girls? Linear, carbon with oxygen, gonna cancel each other. What exactly happened with H2O? It was a bend shape. If this would have been linear, then it could have been 0, but over here, this is how it is, right? But guys, pay attention. In the case of water, where it is H2O, the dipole moment is 1.85. But when we talk about H2S, the dipole moment decreased. Why is that? I'll tell you. So if it is sulfur, hydrogen and hydrogen. Sulfur is not electronegative as oxygen is. Sulfur is electronegative but not as electronegative as oxygen is. Hence the dipole moment, the charge separation is going to be small. That's the reason I'm making small arrows. I'm making smaller arrows if you can actually see. The charge separation in the case of sulfur and hydrogen is going to be less. Higher the delta En, higher is the charge separation. Higher is the charge which is getting separated. Okay, so do remember that. That's the reason the dipole moment decreases. Okay, so higher is the electronegative central atom, higher is going to be the dipole, is what you have to remember if the dipoles are not getting cancelled. And similarly, in the case of BF3, 120, 120, 120, 0. In the case of tetrahedral, again it's going to be 0 if the elements are same. Okay, now let's talk about lattice energy. Let's do one thing. Let's take the case of NaCl. Na plus plus Cl minus. Now guys, pay attention. If I take 6.023 into 10 raised power 23 number of sodium plus. See, for no reason I am making this concept longer. In other words, we're talking about 1 mole of Na plus. Correct? Again, we'll write something. Let's take 6.023 into 10 raised power 23 number of chlorine minus, which means we're talking about 1 mole of chlorine minus anions. What is going to happen if we make NaCl solid? How many number of NaCls are we going to get? 6.023 into 10 raised power 23. That means how many moles of NaCl are we talking about? Correct? Now pay attention. Achha, is there anybody who can actually let me know the molar mass? Yes, the molar mass of NaCl. It's going to be 23 plus 35.5, and after that I am so sorry, but I cannot calculate. I just have to sum it up, but I do not know. Can anybody help me over here? I'm very bad at mathematics. Even I do not know what is 1 plus 1. Is it 2? I could be wrong. Let me know the answer over here. The correct answer to this question is going to be 58.5 grams per mole. Right? So now guys, pay attention. The definition of lattice energy talks about when we take gaseous cation Na plus gas plus chlorine minus gas. Gaseous cation and anions is what we are taking. How many? 1 mole and 1 mole. And when we form their compound, okay, which is going to be solid, obviously, how much energy when both of them, see, this is positive, this is negative, when a negative and a positive are going to come closer, will they love it? I think yes. When something loves somebody else, I mean, when you like something, anything in the world, could it be car, could it be job, could it be profession, could it be anything, obviously you know that that particular thing is going to give you a lot of stability, a lot of happiness. And whenever we talk about even atoms becoming happy, that means they know that they are going to become stable. And whenever things are going to become stable by their own, they release energy. They release their energy. They throw a lot of energy out. So what is going to happen over here? Is this going to be exothermic or endothermic? That's going to be exothermic. A lot of heat will be removed. So when both of them come out, the delta H of reaction is going to be negative. This, whatever negative value is going to be there, that is actually going to be the lattice energy. There are two ways to understand lattice energy. There is one where you bring both of these 1 mole and 1 mole of cation and anions together and form 1 gram mole. What is 1 gram mole? What is 1 gram mole? 23 over here, 58.5 grams, of NaCl. Whatever is the molar mass, that much is 1 gram mole. Okay. So now that means, in other words, we're talking about just 1 mole of NaCl. If we get this, how much energy is released is the lattice energy. Or if I provide the same energy which is released, let's say for any two cations and anions coming up, there is 50 kilojoules per mole of energy getting released. If I provide 50 kilojoules per mole to the compound and ions go off, ions go away from each other, even that is the lattice energy. So lattice energy is the energy released when gaseous cations and anions in good proportion comes and forms up their compound 1 mole, or if we provide that same energy to break those cations and anions apart, the same energy, that is the lattice energy. So energy to break the lattice or energy to form a lattice. Do remember this. Is this clear? Let me know. If not, I'll take it again. Come on, let me know. Divi Verma, you're going too far. I mean, you're lagging actually. 23 grams. What are we really talking about? I didn't talk about 23 grams over here. Bhaiyo or Behno, Ganesh. Hey, anti-Korean Chinese. Okay. Happy Ganesh Chaturthi to you as well. Clearo? Amazing. Amazing. Now, let's move ahead. Yeah, this mic of mine, I think this mic and my war is never going to end, right? Chalo. Now let's talk about hydration energy, because the concept of hydration energy is too much higher, is of a good level, so we'll talk about this. So we're talking about energy released when 1 mole of gaseous ion undergoes hydration. We'll talk about this. Pay attention. So now let's talk about lithium plus. Achha, let's talk about not lithium. Let's talk about atoms first. So we're talking about group 1. What exactly happens when we go down the group? Does the size increases or decreases? The size increases. And why is that? Number of shell increases, right? And Z effective nuclear charge decreases. Is there anybody who doesn't know what's the effective nuclear charge? You have to go back to the periodic table chapter. Now, hydrogen, lithium, beryllium. Oi, she, ganda bacha. I'm writing the period down the group. Okay, hydrogen, lithium, and then we have sodium, potassium, rubidium, cesium. Write ganda bacha in the chat. Everybody, write ganda bacha in the chat. Okay. It's not about me alone. Every teacher struggles with these wires. Yes, I'm thinking of going for wireless, but I'm not really sure how the transmission is going to be. Is it going to be good enough or not? But anyhow, now let's talk about these. As we go down the group, size, atomic radius increases. Correct? And now guys, pay attention. Over here, what are we really looking at? I'll hold this in my hands right now. Okay. So now let's compare lithium and let's compare cesium. Okay. Lithium has an electronic configuration as helium 2s1. Correct? So now guys, pay attention. Second period, third, fourth, fifth, sixth. Okay. And when we talk about cesium, what is going to be the electronic configuration? And just to get the noble gas like configuration, lithium and cesium, as all group 1 elements like lithium, all the alkali metals, can actually show removal of 1 electron, and they can actually become lithium plus, cesium plus, sodium plus, potassium plus, rubidium plus. Correct? Now guys, pay attention. Which is having higher size between lithium plus and cesium plus? Obviously, because still it is having 5 shells. This is having just 1 shell right now. So the size of the lithium plus is going to be this much. Not according to scale. Okay? Just comparison. Size of the cesium plus is going to be this much. Let's say. Cool. Cesium plus is going to be much bigger. Now guys, pay attention. How much charge are these both occupying? Both of them are actually occupying the same charge. Which one is having a higher charge density? Which one of them is having higher charge density on the surface? Let me know. Bigger atom having 1 charge, smaller atom having 1 charge. It's actually going to be lithium plus having higher charge density. Small size but having same power. Bigger size but having same power. The charge density is higher over there where the size is small, is always what you have to remember, right? I'll give you one more example. For those who are not able to understand this charge density, I'll give you the best example. Nobody in the world can give you this. Okay, wait and watch. Now what exactly is happening? We will not talk about charges, we will not talk about atoms, we will talk about Fevicol and some small beads. Some beads where you actually do some art and craft, small spherical beads. So let's say you had a small bead, this one, and you have a bigger bead, this one. And guys, think about it. I ask you to dip both of these balls in a plate where there is a lot of glitter. A lot of glitter is there. See, I'm supposing that all the girls are active right now, because I feel a lot of girls actually like art and craft. Do you or not? Even I'm not saying it's I'm not generalizing anything. Even I liked art and craft a lot. But yeah, majorly is what I've seen. You can disagree as well. But now, jokes apart, you have both the beads, okay? And I want you guys to actually dip both of these beads into the glitter, these stars or powder, whatever, and I want a coating of the glitter on the beads. What I'm giving you is 1 drop Fevicol onto this bead, and again 1 drop Fevicol onto this bead. Okay, yes or no, boys and girls? Can we do that? I'm saying you are not allowed to use some more amount of Fevicol. Same, 1 amount of this one and 1 amount on this one. Which bead do you think, bead A or bead B, will be the one which is having gaps, where you can actually say, not the whole surface is covered by the Fevicol. There are some portion where the Fevicol is not there. Which one of them is going to be the one? The smaller bead or the bigger bead? It's going to be the bigger bead, which is going to have some gaps on the surface, right? Where it is, the Fevicol is not applied properly. But to the smaller bead surface, it will be evenly spread. Correct? Now, over here, guys, pay attention. Now you dip both the beads inside. Which bead is going to have the surface completely, covered by glitter? Again, that is going to be A. And bead B is going to be the one where the glitter will be applied all over the bead, but as there are gaps of Fevicol, there would be gaps on the surface where the glitter wouldn't be applied, right? So there will be patches of glitter over here, but this bead is going to be completely, covered. So do remember, smaller one is completely covered. Efficient surface, the surface is efficient over here. The surface over here is not efficient. So if you're talking about one drop of Fevicol, that's the same positive sign, same charges, same amount of Fevicol. Okay. Now guys, keep this in mind. Whenever we are going to talk about lithium plus and cesium plus, this is a bigger ion, this is a smaller one. And I am showing you the water molecules. Guys, I'm showing you oxygen closer to the charge, closer to the cation. Why is that? Because oxygen always have partial negative character, and partial negative attracts with positive, and partial positive is repelled by positive. That's the reason only oxygen. So guys, just because of this positive sign, oxygen available, which is there in water molecule, comes closer and surrounds lithium plus. This also happens over here. But why have I made less water molecules in front of cesium, around cesium plus, and more water molecules? I can make more actually. I can make more over here. Okay? I should actually make more. But more water molecules around lithium plus. The same thing. The same thing that you did over here. Acha, I removed it. Okay, I'm sorry. You know, the bigger the bead was, there were gaps, there were patches, empty patches on the bead surface, right? But for the smaller one, it was not. Same thing is happening. What is the Fevicol over here? One drop of Fevicol is this. One drop of Fevicol is this. But around a bigger bead, less, I mean, you know, there are going to be patches. Where are these patches? Here's the patch, here is the patch, here is the patch, where the glitter is not available. But in the case of lithium plus, there is no, you know, available place where I can clearly say that the glitter is not applied. And what is glitter over here? You guys have to let me know. What is a glitter over here? I've told you what is Fevicol. I've told you which is a bigger bead or a, you know, smaller bead. But what is the glitter over here in my example, in this analogy? And even you can rate this analogy as well. Did you like this to understand the topic? Because over here the topic is not still over. I am going to teach you more. The water molecules. Yes, the water molecule is the Fevicol. Okay, so do remember this. Now I am going to ask you something. Why do you think more water molecules are coming closer? Are these water molecules not going to repel each other? This could be a question in your mind. Over here, less water molecules are coming. Do you think water molecules are coming over here because they are loving it? Because they are ultimately happy to come? They know it. It's okay to come. I am going to be happy. I am going to be stable. Higher the stability, right? So over here where more water molecules are coming, that means more water molecules are going to be happy. Here also water molecules are going to be happy, but less water molecules are going to be happy. Here more water molecules are going to be happy to come closer. Hai na? So now stability is going to be good. Do you think there will be a too much loss of energy? If stability is double good, can I say there will be too much loss of energy? Where stability is also going to be good for the water molecules, and energy is going to decrease. But where do you think the energy will decrease more? In the case of lithium plus. Why? Because water molecules are more happy here to come. Wow, we have a positive charge, we'll have a good time. Oh, there is a positive charge as well, but it's okay. The charge density is less. Over here the charge density is more. And now pay attention. When there will be a lot of energy removal, when a lot of energy will be released, to make the energy level, if this is the energy level of, you know, lithium plus and the water molecules around, the energy of the system will decrease. And then ultimately, whenever there is a loss of energy, energy is always released, right, in some form or the another. Hence, the hydration energy is the energy released. Okay, so now look at the definition. Energy released when 1 mole of gaseous ion, lithium plus or cesium plus, whatever gaseous ion you're talking about, undergoes hydration. Hydration means water molecules of, you know, this hydro, and water molecule of water. I mean, water molecule of water nahi, molecules of water surround the gaseous ion. Okay, it could be anion or cation. I'll ask you one more thing. Now, where do you think that the hydration energy is going to be more? Pay attention. Hydration energy is going to be more in the case of chlorine minus or in the case of bromine minus. Do remember, when we go down the group, the anionic and the atomic sizes increases. Let me know. (11 on 10 for analogy. Amazing, amazing. Thank you so much, boys and girls. Molecules of water. Yes, even water molecules of water. Okay, chlorine minus or bromine minus? Come on. Which is going to have a better hydration energy? It's going to be chlorine minus. It's going to be chlorine. Smaller the size, smaller the size of ion, higher is the hydration energy. And now you will be like, sir, no, oxygen atoms will not come closer to chlorine. Correct. But in the case of chlorine minus, or in the case of an ions, partial positive hydrogens come and surround. Right? In the case of bromine also, water molecules will come to surround chlorine minus, but less number of water molecules will come, because hydrogen, partial positive hydrogens will be like, okay, the negative charge over there is less. Charge density is higher where the size is smaller, because the amount of charge is same. Yes, got it? Chlorine minus, smaller size hai na? Amazing. You guys should give yourself 20 upon 10 marks. Everybody, write your name or write each other's name and compliment each other, because complimenting each other can give you a lot of confidence. Okay, so do that for yourself. And now, and anyhow guys, for those who are actually watching this class for the first time, every day 9 p.m. we do classes. On TTS we do class 12 chapters. On MWF we do class 11 chapters, is what you should know. Got it? Amazing. Now let's talk about Fajans rule. Whenever we talk about Fajans rule, it's all about fraud. I call it fraud. Okay? So how is it going to be? Even I have a good analogy over here. Now guys, think about it. Let's say sodium is there. Sodium is having 1 valence electron. And chlorine minus is there. Chlorine is there, not minus. Having 7 valence electron. Chlorine asked sodium, can we share this electron so that I become NS2, NP6, I'll become stable. But in this scenario, if sodium will share this electron, sodium will become 2s2, 3s2. Sodium says, no, I don't want that. I want noble gas configuration. Then they actually conclude that I am going to give you this entire electron forever, so that I become sodium plus, which is a neon like configuration, and you can become minus with the argon configuration. Deal is good? So think about, you are in trouble and your friend says, see, I have a lot of money. Your friend says, I have a lot of money, you take some money from me, I'll never ask that I gave you money, give me back or something. Just like sodium did. Sodium gave electron to chlorine and sodium said, I will never ask you to give me that electron back. But what decides that the electron has to be exchanged or electron has to be shared? Electronic configuration decided. The number of electrons available in the shell, in the orbitals, decided by their own. Okay? But later what exactly happens? Over here the number of protons are 11 and number of electrons are 10. These protons are not happy. Why? Because these protons want electrons. One proton is having 0 electron. See, 10 protons are having 10 electrons. One extra proton is having no pair, no friend. Acha. So now this friend of yours who gave you money and said, I will never ask you, ask for the money back, now starts asking, or now starts showing, telling you every day, hey man, I gave you money that day, I helped you a lot. He does that every day. So is it a good thing? I mean, if he had to tell me every day that I actually gave you money, he should tell me on the first day, right? Or I would have given him back. That's what you would do. You would give him back, right? If he would have said, I want my money back within 2 days, correct? But he actually told you on the first day that I will never ask back. But now he is reminding you every day. Is it a good thing? Technically no, right? This is what Fajans rule, comes in. I'll tell you. Sodium initially bragged about electron, or take it, I don't care. Later sodium's protons are not happy. Sodium's protons are not happy. This positive charge now attracts the negative, the electrons, electron density. So what was the size of chlorine minus? We will talk about this. So initially when we made chlorine with 7 electrons getting 1 more electron, which is minus, this is the shape of the electron cloud, uniformly distributed around the nucleus, all 8 electrons in the outermost shell. But when sodium plus starts crying I want electron, I want my electron back. Now what exactly happens? The electron cloud gets distorted, the shape changes. Will it go close? The electrons are negatively charged, right? Will the shape of the cloud will come closer to the sodium plus, or will it go far away from the sodium plus? What do you think? Electron cloud is negative, sodium is positively charged. Think about it and let me know. So this is how it is going to be, guys. The newer one, sodium is now asking for the electrons back. Okay, you're getting it? These are getting attracted towards sodium plus, closer to sodium. This is what is exactly happening. Now I'm going to ask you one more thing. Okay, now instead of sodium plus, if I bring lithium plus, will the shape become much worse? Will the electron clouds will come more closer to lithium plus, or will it get relaxed? What do you think? Remember, the charge density of lithium plus is better than the charge density of sodium plus. Smaller size, higher charge density. Over here, what is going to happen? I'm going to show you again. I'm going to use blue. In the case of smaller cation, this is what is going to happen. Is this clear? Now, is it more like, so when the electron cloud distorts more and more, when the electrons are coming more closer towards the cation, is it ionic? Is it an example of ionic character or a covalent character? Electrons are coming more closer to towards the lithium as well. I think this is more like a covalent character, right? It is not exactly 100% exchange of electron. This is more like giving it and then taking it back and keeping it in the middle. My friend is there, I gave some money to him, and now I'm keeping it in the middle, right? Or maybe I'm giving him an ice cream, I say I don't want that, and then later I keep it to myself as well. So that's actually sharing, correct? So this is what it is. So whenever you see a smaller cation, it is actually showing less ionic character, more covalent character is what you have to remember. Are you guys getting my point? Now I'm going to ask you one more thing. What if instead of lithium plus, I put cesium plus? Is the electron cloud distortion going to extend more towards the cation, or is going to get relaxed? Over here, it is going to get relaxed, because the charge density of cesium plus, see, charge is same whether it's lithium plus, sodium plus, potassium plus, rubidium plus, cesium plus, but higher the size of the cation, ultimately now it is not exactly going to be closer to chlorine minus, but it is going to get relaxed. See, it's not exactly like how chlorine minus was individually there. So this is the chlorine minus when it was individually sitting, when there was no cations around. The yellow one, for the cesium plus it's white, for the sodium plus it's green, for the lithium plus it's blue. Gradually to share electron. Yes? Okay, are you guys getting it? So now what are we really going to remember? So now do remember this size, when the size of cation decreases, becomes smaller, polarization increases. Okay? What is polarization? The distortion that you were looking at. Electron cloud coming more and more closer towards the cation. That is polarization. Okay? So this is polarization, polarized anion. Not like this. This is unpolarized anion. This is polarized anion. Is this clear? Do remember this. Now the topic is not over, and neither I am going to settle, and neither you should be. We're doing more. I'm going to give you another example. Let's say there is a case where sodium plus is available and chlorine minus. What is the shape of the distortion? I am making it like this. I'm going to ask you something. If I have magnesium plus 2 plus, what is going to be the shape of this distortion, this polarization? Is it going to be more polarized or is it going to be more relaxed? Let me know in the chat. Magnesium 2 plus near chlorine minus. Will this become more polarized? Will this anion become more polarized? Let me know. Or less compared to when sodium plus polarize this chlorine minus anion. It is going to make more polarized. Why is that? Plus 2 charge is much more stronger. The electron cloud will come much more closer towards the magnesium. More. And do remember one more thing. Sodium is here, magnesium is here, and lithium is here. Compared to lithium, sodium is much more electropositive. Compared to magnesium, sodium is much more electropositive. As we go down the group, electropositivity increases. As we go across the period, electropositivity decreases. So sodium is going to be the electropositive one when compared to lithium and magnesium. Correct? Do you remember the electronegativity values? You should know it, right? 1.0, 0.9, 1.2. Now pay attention. You know this. The more electronegative element forms lesser ionic compounds. I mean, the ionic behavior is going to be lesser. The covalent behavior is going to be more. That's the reason fluorine, oxygen, nitrogen, all of them, try to show you the covalent characters. And whenever they form bonds, hardly their bonds are, ionic. When they're not, when they're not making up with the metals, apart from metals, okay? So that's what you should remember. If the electronegativity is higher and the delta En value is less, bonds are covalent between atoms. Over here, if I am actually having sodium and if I'm actually having magnesium, and let's say we talk about fluorine and chlorine. So if you talk about chlorine, now guys, do you remember the electronegativity value? 3.2. What is the difference between the electronegativity value of 3.2 and 1.2? It's delta En comes out to be 2. In the case of 3.2 and 0.9, delta En value comes out to be 2.3. Where do you think the ionic behavior is going to be more? It's actually going to be more where delta En is more. So between sodium and chlorine, ionic character is going to be more. And this particular concept is explained by Fajans rule, where sodium plus does not bring more electrons towards itself, but magnesium brings more electrons, not electrons but electron density, electron cloud towards itself. Here the covalent character is more, ionic character is less. Here the ionic character is more, covalent character is less. Will you call magnesium chloride, the bond between magnesium chloride, as ionic or covalent? You should still call it ionic, but we cannot call it 100% ionic. Never say 100% ionic. There will be some amount of sharing. Let's say 90% ionic, 10% sharing. That's what you have to remember. It's not taking that electron back entirely. The charge remains still there. So do remember this. So now the second step, the second information that you have to note, which is higher the charge on cation, more is the polarization. Do remember this. So polarization is directly proportional to the charge of the cation. Polarization is inversely proportional to the size of cation. Size of cation. Do remember this. Okay. These are the two information that you have to remember, which is related to cations. Now we are going to talk about anions as well, and I'm going to talk about that right now. Let's say you have sodium plus in both the cases, but you have chlorine minus and you have bromine minus. Where do you think the polarization is going to be more? Remember one thing, the chlorine minus have smaller size, the bromine minus have a bigger size. So if that extra electron which is taken from the sodium goes to chlorine and bromine, as the electron for the bromine goes to the outermost shell, which is way much far away from the protons of bromine, it becomes hard for bromine minus to control that extra electron. But for the chlorine, it is much closer to the protons of the chlorine. This extra electron, which is creating this negative charge, it's easier for chlorine to control. But as the size increases, it becomes hard to control that extra electron, right? This is what you have to really remember over here. Pay attention. Now in the case of sodium plus, how will you see the polarization? Okay? And when we talk about in the case of bromine, the polarization is going to become more. Is this clear to each and everybody? Why? Higher the size of an ion, it becomes tough for the anion to control that extra electron. And you have a positive charge, that electron comes much more closer towards the cation. Here polarization is becoming more, and wherever you see more polarization, covalent character is going to be more. Ionic character decreases. You getting the point? So do remember one more thing. Polarization is directly proportional to the size of an ion, but inversely proportional to size of cation. Inversely proportional to the size of cation, but directly proportional to the size of an ion. If the size of the anion increases, polarization increases. Clear? Got it. Amazing. And now let's talk about the last one. Let's do it. The last. Pakka. Promise. Okay. Let's do this. But anyhow, not the last topic for this class. I am going to make sure your syllabus gets completed. So we're not ending up over here. Now let's say you have sodium plus and you have sodium plus. You have, let's say, chlorine minus and you have, let's say, sulfur 2 minus. The unpolarized ion, where do you think the size of the anion is going to be more in the case of chlorine, in the case of sulfur 2 minus? Chlorine minus, sulfur 2 minus. Higher the negative charge, electron repulsions, one electron pushes another, hence due to this fight the size of the anion increases. Chlorine minus, see if this is chlorine minus, but sulfur 2 minus is going to be much bigger because extra number of electrons push electrons each other, they push each other away. So this is where the unpolarized S2 minus is going to have a bigger size than, again, chlorine minus. Where do you think the polarization is going to be more? Wherever the size of the anion is going to be more, there only the size, the polarization is going to be more. Or even you can talk about wherever the charge is going to be more, polarization is going to be more, because -2 charge is going to love. -2 charge is actually desperate of having a positive charge, and -2 charge is going to be desperate about the positive charge. -1 charge is going to be desperate as well. So polarization is less. Over here polarization is more. So what will we write? Polarization is directly proportional to the charge of an ion and directly proportional to the charge of cation. So if the charges increases, polarization increases. Okay? So do remember this. And now you should remember, wherever polarization is more, covalent character is more. I'm not saying that magnesium, if polarization is more in the case of magnesium and chlorine compared to sodium and chlorine, you cannot say magnesium chloride is actually covalent in nature. No. In sodium and chlorine, you can actually understand it like this. Sodium and chlorine is having the polarization where ionic character is 90, covalent character is 10%. In the case of magnesium chloride, it becomes 85% ionic, 15% covalent, something like that. Okay, still things remains ionic, but not 100%. That's the reason we all say no bond is 100% ionic, is what you have to remember. And no bond is 100% covalent between two different elements, between hydrogen, between fluorine. Yes, 100% covalent character is there. Now let's move ahead. Okay, so now everything is what I have told you guys. I can't repeat these, and I have summarized this all for you. What is directly proportional, what is, smaller the size, higher the polarization. Higher the charge, higher is the polarization. Increasing electrons, directly proportional to the. So that's what we are talking about, okay? And now let's do a question. Among the following, maximum covalent character, that means maximum polarization, where do you think? Read the question like this. Chlorine, 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 chlorine. The anion is same. So you just have to compare the cations. You just have to compare the cations over here. Let's do this, boys and girls, right now. Come on, let me know. See, what is the charge on iron? Just because there are two chlorine minus, two chlorine minus, yes. So ultimately the plus 2, plus 2, plus 3, plus 2. Anyhow, you can see the odd one out. And higher the charge of cation, higher is the polarization. Polarization is good in the case of A, B and D, but in the case of plus 3 cation, the polarization is going to be more. Wherever you see higher polarization, ionic character is going to be slightly less comparatively. Higher is going to be the covalent character, and C is going to be the correct answer. Right? You liking it, right? Wow. Because you know what, guys? If you know the best chemical bonding, then I am going to guarantee you this. You are going to have the best in organic chemistry. Remember that. In your batch, you are going to be the smartest, the smarty pants, as Khushi says. So you are going to be the smarty pants when you are actually diving into any inorganic chemistry question. And even it helps in organic chemistry as well in a lot of different places. Okay. Now, lattice energy of an ionic compound depends upon. What exactly? I told you. When this lattice energy is the energy which is released when cation and anion comes together. 1 mole of cation and 1 mole of anion, if it is plus and minus charges. What brings them? Why the hell they're coming closer? What makes them bring closer and become happy? Is it the charges? Right? Is it the charge density that we are talking about since so many minutes? Exactly. Charge density depends upon the charge and the size. Charge on the ion and the size of the ion is going to be the correct answer. It's nothing but the charge density that we're talking about. A is the correct answer. Amazing, right? And now let's talk about the VSEPR theory. It's a very amazing theory, and even the name tells you every damn thing. Let's read it. We are going to read it like valence shell. Valence shell means outermost shell. Valence shell, electron pair. Let's talk about 2 electrons. Electron pair, 1 pair is 2 electrons, right? R stands for repulsion. Now let's pay attention. If we have nitrogen or any particular element, I'm just taking up an example. How many valence electrons? 5. 1, 2, 3, 4, 5. But whenever we talk about electron pairs means bond pairs which have bonded, which have paired from other element, and lone pairs which didn't bond, which didn't get shared by any other element. Do you see a lone pair? This is an electron pair. Do you see bond pairs? Let's see. If I am having ammonia, now guys pay attention. This is 1 pair, this is 1 pair, this is 1 pair. These are 3 bond pairs. This is the lone pair. Now do you think that this lone pair is going to repel bond pairs? Yes or no? This is also, these are also electrons, these are electrons, these are electrons, these are electrons. Are these electrons going to repel each other? Yes, right? But now, which all type of electrons got the chance to get paired? These are more happy, is what you can remember. These ones didn't get the chance to get paired. So this one is having slight amount of jealousy. not jealousy is not a very good word, nobody is jealous of anybody, unhappy, angry. Okay, now the one which is angry, what exactly the angry lone pairs do? They repel bond pair more. So if this is nitrogen and the bond pairs should be like freely available, and these are the lone pairs, they push more, like an umbrella. Like, you know, if you actually open up an umbrella, this is how you open it up, right? Think of something at the top trying to repel it, trying to push it back. How will the umbrella become? The umbrella will become like this. It will slightly close, right? The angle will decrease. See, the angle at the joint will decrease, right? That is what exactly going to happen over here. So when the lone pairs repel bond pairs, then these bond pairs come closer. Initially, where were these? These two I'm talking about. This was the initial position. But pay attention, if lone pairs repel bond pair, why can't this lone pair simply close the umbrella? It can do it like this way as well, no? Repulsion simply close the umbrella. You know, it actually made the umbrella get closed. That does not happen. Why? Because when one bond pair and the another bond pair comes closer, now bond pair also repels each other. So there's a point where lone pairs will be able to repel bond pairs, but bond pairs are also going to repel each other. So they will stay at some particular angle. Okay, na? So do remember this. Whenever we talk about lone pair repelling lone pair, repulsion between lone pair and lone pair, I'm talking about repulsion. That is the maximum one. One angry lone pair with the another angry lone pair. Too much of fight. When we talk about a lone pair repelling a bond pair, okay, because bond pair is not that angry. But when we talk about a bond pair and a bond pair repulsion, it's the least. Though they repel each other, but whenever they are very much close, you know, so they are not really going to push lone pairs away. Okay, na? Lone pairs push, bond pair too much high. Okay, is this clear to everybody? And this repulsions is what we are talking about, only related to valence shell and between electron pairs. That is valence shell electron pair repulsion theory. That's it. Nothing more in this theory. Amazing? Yes. So now let's move ahead. And this valence shell electron pair repulsion theory actually tells us what should be the angle, what should be the shape of the molecule. We'll talk about this. Okay, we'll talk about this. So now this is what we're talking about. Now guys, pay attention. What if this is you? This is you. I'll take some names, the most active ones in the chat, the most recent ones. This is Mikey. This is Mikey. Okay, and we have Khushi and we have Pragya. Okay, so the guys, now pay attention. Let's say in this class, Pragya and Khushi are fighting to each other. Which is Pragya? This is Mikey. This is Khushi. Khushi and Pragya are fighting with each other. And Mikey is a friend of both. How do you stop your friends from fighting? Are you like, if my one friend and the second friend is fighting, I am going to keep them in front of each other and I'll be like, don't fight. Or are you going to be the one who's going to keep one at one end and second at second end? Will you try to keep them at an angle of 180 degree? When two people are repulsive to each other, when two people are fighting with each other, it should be a 180 degree angle, right? If you are simply going to keep both of them away with an angle of, let's say, 20 degrees, 30 degrees, then ultimately they are going to fight, right? Right? You want them to fight. So now, what is going to be the angle, boys and girls? It's going to be 180 degree. That what is exactly happens over here. When we are talking about, let's say, carbon, which is having no lone pair when it is compared with the double bond O and double bond O. Are there any lone pairs? No. One bond pair, bond pair. When bond pair and bond pair repel each other, carbon keeps it or these repulsions, because of these repulsions, they stay exactly opposite to each other, so that the repulsion is minimum. Now they can't simply go away, right? Because there has to be a bond. But if they stay closer, there's a repulsion. If they stay closer, there is a repulsion. And in any direction, if they come closer, there is a repulsion. The best way is staying 180 degree away from each other. So higher the angle, the more away they are from each other. That's what you have to remember, okay? So that's where the shape of the linear molecules is all because of the bond pair repulsions, okay? So this is what we're talking about. Let's say B, E, F and F. Bond pair repulsion, angle between them 180 degree. It's going to be linear. Now let's talk about more. Mikey gonna be like, let's stop here guys, otherwise I'm gonna call Mikey and Minimus. Okay, okay. You guys can have a lot of jokes and fun in the chat. Now let's talk about more. Now let's say there are 3 friends and you are the 4th one. 3 of your friends are fighting. This is Mikey. This is Mikey ka friend 1, Mikey's friend 2 and Mikey's friend 3. Okay? Will you keep them at an angle of 120 degree, or will you keep them something like this? This is Mikey, this is friend 1, this is friend 2 and this is friend 3. Will you be able to stop them if this one hits this one, or if this one hits this one? Or is it going to be like that you have to stand in the middle, or maybe like a South Indian movie scene where the actor has to be in the middle, right? And all the other villains are going to be surrounding him, at an exact within exact uniform distance. One is going to be here, one is going to be here, one is going to be here, and they actually have a uniform distance between each other. Correct? That's what we're talking about. Which is a more efficient formation? What do you guys think? Right? Even let's say you are trying to catch somebody. If police wants to catch a thief, is it going to be like, the police are going to stay like here, and so that the thief can run away from here? Or is it better to catch him from every direction and then keeping the thief in the middle? That's the better way, right? So you can take any example that comes in your brain. Okay? But over here, the best angle which comes for 3 bond pairs is 120 degree. And this is what you see, trigonal planar. How is this trigonal planar? The central atom, one more atom, one more atom, one more atom. All these 3 atoms are in single plane, and the thief is in the middle, in the same plane, on a same piece of paper. Okay? And if you guys are really liking the analogies that I'm actually using over here, you should promise me that you are actually putting up the attendance, and you should, for these analogies, you should share these videos amongst your friends. You can actually let them know the timestamps as well, that at this point of timestamp, what analogy did I use or what topic did I explain. That's on you guys, okay? But now, over here guys, pay attention. What are we really talking about? Now let's talk about 4. Pay attention. Is it good that I keep, if I have 4 bond pairs, I keep 4 of my friends like (90 degree, 90 degree, 90 degree, 90 degree? Is this a better situation? Or, because I anyhow said, right, higher the angle between 2 bond pairs or electron pairs, lesser is going to be the repulsion, right? Is this better? Or if I am actually keeping the the friend you over here, let's say 109 degrees, 109, 109, 109, somewhere around 109 or 109.5, let's say. I'm talking about carbon and hydrogen, so then it will become 109.5 approximately. But guys, you let me know. Where do you think? A 90 degree angle between 2 people. One is here, another one is here. I'm trying to keep them separate. Or if I can keep them separate at 109 degrees, one is here, one is here. Which one is better? This one? Or am I keeping in the second case these 2 people away, or am I keeping these 2 people away in the first case? Let me know. Come on. It's going to be better in the case of 109.5 degrees, right? So this is what you should remember whenever we talk about 4 bond pairs or electron pairs. The shape, the electron geometry where the electron pair should be kept, it's going to be tetrahedral and not square planar. Okay, yes or no? Okay, now let's move ahead, and similarly whenever we're talking about 5, so it's better that you keep 3 at one plane, because the angle becomes 120 degree, 120 degree, 120 degree, and the 5th one on the top, which is going to have an angle with the plane which is 90 degree, and another one which is again having a 90 degree. So you keep one friend in front of you, second friend at 120, third friend at 120, fourth friend up, fifth friend down. Okay, on the another floors is what I'm talking about. Or even you can remember something like a pizza slice, a big pizza slice, one friend over here, one friend over here, one friend over here, you are at the middle, and a toothpick, you just do it for a decoration, just to understand this particular concept, and try to assume that there is a toothpick, okay, or anything, any stick at the bottom. That's how it is going to be. This is going to be the trigonal bipyramidal. And why bipyramidal? Because this is trigonal planar. See this, one pyramid is, guys, what you can see, one triangle and one pyramid, right? Now guys, pay attention. This is one pyramid. Okay, second pyramid is what I'm going to talk about now. This is the second pyramid. If I'm going to remove the first one so that you can actually focus on the second one, this is the second one, right? Trigonal base, and then the peak is at the bottom. Yes or no, boys and girls? Come on, are you guys getting it? Antara he has some big memories with pizza. Who? Why every time pizza? I love pizza. I love pizzas too much, too much. Okay, even in, if I am talking about, pizzas so much, it could be that, I'm going to order a pizza later. So I actually sometimes work hard, give you a lot of good analogies so that I can actually order a pizza later. Okay, amazing. So this is how you can always remember. You can always take any book and you'll get the correct data for the number of electron pairs, EP, electron pairs where it is going to be the bond pairs. For let's talk about 0 lone pairs, then 1 bond pair, another bond pair. It's going to be linear. Then we are going to have 3 bond pairs, 3 bond pairs and 0 lone pairs. Shape. What if we have 2 bond pairs and 1 lone pair? Bent shape. Why the hell it is a bent shape? Because whenever we talk about the shape of the molecule, you should always remember we never take lone pair into consideration. What is the shape, guys? Do you see a lone pair? The electron geometry includes bond pairs and lone pairs. Electron geometry is trigonal trigonal planar, but the shape of the molecule is all because of the placement of atoms wherever the atoms are available. Do you see a bent shape? That's what we are talking about. Shape of the molecule is because of the atoms placement. Shape of the electron geometry is because of the positioning of lone pairs and the bond pairs. So do remember the difference. And now let's talk about bond pairs 4, tetrahedral, bond pairs and lone pairs including 4, again tetrahedral, 1, 2, 3, 4. But the shape of the molecule, neglect the lone pair for now. Trigonal, pyramidal. When we have 2 bond pairs and 2 lone pairs, again the electron geometry is tetrahedral, same electron geometry, but the shape bent. So always remember this, okay? So this is how you can actually do it for n number of cases. When we're talking about electron pair 5, so we have 4 bond pairs and 1 lone pair, let's say. Then ultimately you should remember how many positions do we have? 1 trigonal planar, 1 over here, 1 over here. If I keep 1 lone pair over here, then what is going to be the shape of the molecule? Let's rotate this. It's going to be like, what is the shape? Seesaw shape. So guys, this is going to be the seesaw shape. Do you see? Right? So this is how you should always remember. Okay? Is this clear to each and everybody? Kal sir ka birthday to nahi hai na? Nahi bhaiya, it's not my birthday. When did I say? Who said it that it's going to be my birthday? Pay attention over here, boys and girls. Come on, I'm putting my throat out. I'm actually, saying everything loud enough so that you can actually focus over here. We'll talk about that. We'll chill. We'll do a chill session. It had been a long time, so don't worry about it. So now let's talk about few questions. The questions talks about, and guys, do remember, whenever you're talking about if you want to know the exact number of lone pairs and bond pairs, the only thing that you have to remember is calculating the electrons, valence electrons of the central atom correctly. In CO2, which is the central atom? Carbon. In the case of BF3, boron. So you should always count the valence electrons for the central atom very well. And generally you should remember, central atom in such type of molecules is always less in number. So now in xenon F2, xenon F4 and xenon F6, in all the 3 cases, which one of them is the central atom? Xenon, and not the fluorine. But now do remember, how many electrons does xenon has, the valence ones? 1, 2, 3, 4, 5, 6, 7 and 8. Correct? Now guys, pay attention. If I give randomly 2 electrons to fluorine, how many bond pairs? 1 bond pair, 2 bond pair. How many lone pairs? 1, 2, 3. 3 lone pairs and 1 bond pair. You know what is going to be the structure? How many electron pairs are we talking about? We're talking about 5 electron pairs. I'm going to ask you the shape of the molecule. I'm not talking about 2, 3, 1. Rubbish question. Let's talk about the shape of the molecule. Let me know. Shape of the molecule. How will you write? Xenon. 5 electron pairs. Trigonal bipyramidal is going to be the electron geometry. Lone pair at one pizza, corner. Slice of the corner of the pizza slice. Okay? These are the lone pairs. Where will be the bond pair? Something like this. Do remember this. Can this be the scenario? Can this be the scenario? Yes or no? Good. Now, let's talk about xenon F4. Xenon. How many fluorines? 4. Pay attention. 4 bond pairs, 5th and 6th. Total 6 electron pairs. This is going to be square planar, because we are not going to talk about the lone pairs when we talk about the shape of the molecule. We are simply going to remove them from the picture. Let's talk about the last one. Xenon F6. How many fluorines are going to be there? 6 fluorines, correct? 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Now guys, pay attention. Whenever we're talking about 6 fluorines, you should remember there is going to be just 1 lone pair. And where are we going to keep this 1 lone pair? So whenever we talk about the 6, so this is how you have to do. So ultimately the electron geometry always comes out to be octahedral. It is going to be the octahedral, okay? So do remember this. So over here, no, but we are talking about actually 7. 1, 2, 3, 4, 5, 6, 7. So you should remember in this scenario, it is going to be these 5 fluorines, 6 fluorines are going to be in the same plane. Okay. But anyhow, now you guys, you should remember one thing. It's a very easy question. When the valence electrons are constant, 8, 8 and 8. And when the number of bond pairs are increasing, number of lone pairs will decrease. As the number of valence electrons getting more and more bonded, the number of lone pairs are going to decrease. So over here, whatever x value you get, whatever y value you get, and whatever z value you get, the number of maximum lone pairs are going to be there in this scenario. Okay, it's going to be x greater than y greater than z respectively. This has to be a bigger number. Look, let's look for a bigger number. I can see 4. Y should be greater than z. Y should be greater than z. No. 3, 2, 1. Amazing. That's what it, the correct answer is going to be. Clear? Is this clear to each and everybody? Yes or no? Let me know. Okay. And this is where we are actually going to towards the next question. The next question talks about which of the following contains maximum number of lone pairs on the central atom. For that, you should actually know the valence electrons of these central atoms. So chlorine 7, and chlorine having 7, and then 1, 2, 3, 4, 5, 6, 7. Let's not talk about the shape right now. Okay, just so that we can actually get into the answer quickly. How many oxygens? 3. One oxygen having the negative sign, that's the reason it is forming only one bond. How many lone pairs? 1. Let's talk about xenon F4. 8 valence electrons for xenon. 4 of them taken up by chlorine, 2 lone pairs. In the case of SF4, total number of valence electrons 6. 4 fluorines, 1 lone pair. Let's talk about I3 minus. Okay, so write 1, 2 and 1 for all of them. 1, 2, 1. Now pay attention for iodine minus. Iodine 3 minus. Okay. How many valence electrons? 7. 1, 2, 3, 4, 5, 6, 7. Okay. Where is the 8th one? Why? Because of the minus sign. So 8th one because of the minus sign. Okay. Cool. Total minus sign because we're talking about 1 extra electron, or you can do it like this. 1, 2, 3, 4, 5, 6, 7 and 8, and the extra electron that we have made, make it a minus sign. Okay. Now how many lone pairs? 1, 2, 3. That's how it is going to be. 3. I3 minus 3 iodine minus is actually having 3 lone pairs on the central atom, and the question is only asking about the central atom. But there had been a previous question, and you know what they asked? Let us know the number of lone pairs in this ion, not the central atom. You know what students wrote? Numerical type questions. They wrote 3 and they all went wrong. You know what you really have to talk about when they're not talking about central atom, they're talking about the whole ion. Think of the extra lone pairs which are there on the other iodines as well. 3 here, 3 here and 3 here. Total 9 was the correct answer. So do remember this. What the question is asking, for the central atom or the whole ion or the molecule. Okay? Clear? Is this clear? So Pragya ki sun lo please. Okay, face Pragya. Love bhaiya, your students named me Chobu. एकदम मस्त गिफ्ट, वो भी एडवांस में. कल करें वो chill session. Let's do it. Let's do the chill session tomorrow. Okay. Lone pair is equals to steric number minus surrounding atoms. Well, you know what? You can actually remember any different. I would say these type of actual formulas are not really helpful. Okay, you should know why or the number of lone pairs are going to be how much and how. And why. That's what you should know. And ultimately, you should remember this is where we are at the end of this class. If you have any doubts, you can actually message me on Telegram, the group that is there for Unacademy and mine. And you can actually remember that you can actually ask doubts whenever you want. Ask any doubts, anytime, unlimited. Get high quality video solutions in Hindi and English. And you should just click a photograph, click on doubts and solutions, take a photograph, clip it, crop it properly so that we can actually know which question you're talking about, which is the question of interest. Do keep one question in one particular doubt. All the options should and hints should be available so that whosoever is solving up your doubt, it's very much easy for him or her to understand, and they are going to simply give you a solution. Okay? Do's and don'ts: do not provide handwritten material, do not provide multiple doubts in one particular photograph, and make sure the images should be clear. That's it. Okay, now these are the major points that you should remember. And for the scholarship, guys, everybody should go for scholarship, and you should use the code which is LUVGURU to get enrolled for free. This is the biggest scholarship test, happens every weekly on Sunday 11 a.m. and use the code LOVEGURU that you know. Rank 1, 2 and 3 holders are going to get 100% scholarship. Then 75, 50 and 25% scholarship is also available. So do remember this. And absolutely, we're at the end of this class. Like this video, share this video, and subscribe to the channel. And if you want to follow me on Unacademy, do not forget the username, which is @Luv Mehan. And with this particular username, you can actually follow me on any other platform as well if you want to connect. That's it. My time. We are absolutely at the end. Let's meet again. I'm going to be keeping up a chill session for you guys soon. Take care. Bye bye. Tata. Okay, Pragya. Sure. For sure. ठीक है? आज मैंने पिन नहीं किया मैसेज, कोई बात नहीं. It's okay. Bye. Hey, genius Yuva. Bye bye.